Okay, let's start. So last session we were discussing unit testing, and today I want to talk about modules and packages in Python, as well as relative imports, absolute imports, and these kind of things. I think I will use today the official documentation because I want to show you as well how you can use the official documentation to actually learn anything on your own. But before actually going to that, let's make a small recap of how Git works and how you should do your assignments, because there were some questions about it. Um, as usual, do you have any questions that you would like to ask about the homework, about anything that is, administrative, perhaps, about our course? Okay, well, then I will assume that there are no questions. So let me make a small recap on Git. Very simple. Second, let me just go to the repository that we have and I'll work around with it. Okay, let me share the screen here. Okay, so do you see my screen properly? I will assume you do. Okay, so I want to make the whole process of, since forking repository till making a pull request. So let me take the code from a different repo from someone else. I'll just go to a friend of mine's repositories and I'll try to do something with it. So, well, not this one. That's not my friend. Let's see. Okay, so I'll just take any of his repositories and I will try to work with it. So for example, let's take this one here. Okay. So there is this repository and I want to show you how to fork, clone, make your own branches and so on. So what you do here is that you go here to forks and that basically creates a copy of that repository for your username. Okay. And not only a copy, the copy will be actually attached to the original repository. So you will be able to sync it every time that there is any change. Okay. So yeah, I will put here some description so that he knows that I'm just testing. So to show the to show forking and Git pipeline to my students. Okay. Like that. And then well, creates the copy. So you see that now we will create a repository with the same name, because in this case I put the same name under my name. And it says that it's forked from this original repository. Okay. And now you see here there is a button that says contribute. That one is the one that allows me to push my changes to the original repository. And that's how you actually contribute in an open source project in GitHub. And it's very similar um, in other places like GitLab or somewhere else. Okay. So once I have it here, this is my remote repository, and the changes that I make have to be local, right? I have to do them on my IDE or my environment. So I have to download it locally, and that's the process of cloning. So the first step is forking, the second step is cloning, and it's easy to clone. You just go here to the green button that says code, and you see that it says clone, right? There are basically three ways of cloning. One is by using the GitHub's command line interface. I don't use the GitHub command line interface, so I will not use it this way. Then there are two ways. One is by taking the HTTP address, which is basically the standard web link to this repository, or or through SSH. SSH is a different protocol, which we will discuss more in detail in our second semester when we talk about actual software development. Um, I will use SSH just because GitHub has forbidden HTTPS, like to push from HTTPS since 2021, I think. So then you go here and then you copy. There's this button to copy the URL. And now you can go to your terminal and you can just type git clone and paste the URL. The URL in this case, because it is SSH, it will always be something like git@github.com, then my username, and then the name of the repository. Okay. So yeah, I run that command. You see how it downloads the whole repository. It will take a while. Yeah, you can see there are a couple of things there, so it will take some time. Yeah, this internet is not very fast. Okay, cool. So I downloaded it, and now you can probably check that it's there. So I will just show you that it's there. Yeah, I have this folder called brain tumor detection, and I can go to it. So I will move around the terminal. And if you want to learn to move around the terminal in Linux or any kind of Linux terminal, or technically any kind of Unix-like shell, I recommend taking a look at a course called The Missing Semester. You could just Google it. And yep, so this is the link. It's a course from MIT that has the lectures actually published, like the videos on YouTube. And as well, it has a GitHub repository with the assignments and I think it doesn't have the solutions, but it has the assignments and the notes as well. So you can either, if you enjoy watching lectures, you can go through the YouTube, or you can just read the notes, for example. And they have explanations, code, and a bit of theory as well. It's highly recommended, but it's better to do it after you have taken at least an introductory programming class, so that you know what you're doing. So yeah, today I will just show you a bit of how to work with Git. And in our second semester, I will talk more about Git with some technical details. Okay. So I have it there. So now I just move to that folder, and you can see that I'm on that folder. You can see that I have exactly the same files that the remote repository has. Let me show you again here. So you should have an app folder, EDA folder, model notebooks folder, and you have exactly that here, right? EDA, app, model notebooks, and several other folders. For simplicity and convenience for me, I will open this on VS Code. And yeah, you see how I have it here on VS Code. Cool. Now, whenever you have a project where Git is set up, if you have proper configuration on your terminal, you will probably see something like this. It will tell you exactly on which branch you are. So the whole point of Git is that if you want to make changes, you have branches, and branches are nothing more than pointers to specific versions of your code, so are very lightweight. And ideally, and in software development settings, you try to create branches for each feature that you want. It's a good practice. It's not a requirement, but it's quite a well-known method, okay? And you can create a new branch by saying this, git checkout -b, and then the name of the branch. So checkout is actually to move to a specific branch, and basically you will move to the branch related to the feature that you want to implement. And then the flag B here is to say that if it doesn't exist, you want to create it, okay? So here we just say sample branch just to show you, okay? And as you see, it tells you switch to a new branch, sample branch. And now here you see that in green, it tells you that that's the branch. If you don't have that set up and you want to actually check in which branch you are, you can just type branch, git branch, and it tells you exactly which branch you have. It will actually show you all the branches that you have, and it will mark with a star the one in which you are, okay? Cool. So now we are on that branch. And if you want to create your own repository from scratch, your own Git project from scratch, then you just have to type Git init, and it will basically create that, and then you have to start creating the branches, okay? Now, so now let's type Git status, and it tells us what is the status of the branch. In our case, it's a clean branch. We haven't done anything, so for now it's okay. I will just create a random file so that I have some changes. I'll create a random file.txt. Touch basically is a command to create a new file. And now that I have that file, you can already see a couple of changes. Here there is this number here that marks how many changes I have that haven't been in a way added to the project. Like the technical word is that they haven't been staged, but it's not that important. And also because I'm using VS Code right now, you can see here in the source control tab that it tells me, hey, there is a new change from this file. But I will use the terminal just because it's universal and it works with anything, okay? So now, once again, I can type git status. And as you see, it tells me, hey, there is an untracked file, random file.txt, right? And it tells me git add, and then the file name to include that file in the commit. So a commit is nothing more than the action of tracking through history the changes that you want to make. So they will be added to the current branch. And you will see that Git basically creates a directed acyclic graph with all the changes. Okay, so, but again, like this is, like today I just want to talk about very basic things, not that important for, so the really internal behavior of Git is not important for us today. Okay, so then I will do that, git add random file. And as you see, if I type git status again, now it tells me that it is tracked, right? So that will be a change to be committed. And I can either git restore minus minus like staged or like dash dash staged and then the file. And that will basically, it will not include this file on the commit. It will basically go back to this status over here. Or alternatively, because I already added it, I can make my commit. So I can say git commit minus m is a flag for putting a message. And then I can put a message between quotes. And in this case, it will be, I don't know, random commit example. Okay. And once I do it, it tells me, well, in this commit with this message, there is one file changed. There are 0 insertions and 0 deletions. That's because the file is empty, right? Now let me just create it and create another file. I take the same file and modify it. So I will open it here. Cool. And I will just put some random text, okay? Like that. Now I check git status and it tells me, you see, there is a file that is modified. So it's different from the version that we have on the last commit. So we can either restore it to its original status or add that change into the new commit, right? So I will add it. Then I check git status again, and you see how now it says, well, it's on the commit. So we can either make the commit or roll back to the previous one, right? Like on stage. In this case, I will just make a commit. So git commit minus m, and then it's like yet another commit, for example. Once again, it tells me now that one file got changed, right? And there is one insertion because I added one line to the file. Cool. And then if I check git status, it tells me, well, no on branch sample branch, nothing to commit, working tree clean. You see, because I don't have any other changes that haven't been staged. Now, if you want to check the commit history, you can type git log, and it tells you in decreasing order, like as in a stack, in decreasing order of dates, okay? It tells you the commits. So it tells me, for example, this commit made by this author, in this case is me, on this date, at this time, with this message, right? Then this other commit with the same message and so on. And you can see also all the commits from the commits from the repository that was made by my friend, like not the ones that I did, because technically you can see all the history, right? And this is visible because remember that this branch, sample branch, was created from the main branch. So you will see not only the things that I do in sample branch, but also on the parent branch. And you can even see it here that it says that this commit made by my friend was on the main branch, not on the sample branch, okay? Cool. So that's it. And you can also type git log and then you can use, you can specify how many commits you want to see. So for example, if I put minus N3, it tells me that I will only see the last 3 commits, right? Which is cool. Good. So now that I have that, I made some changes locally in a branch that I created locally. I want to do two things. I want to make that branch remote, and I want to push those changes that I did locally into the remote branch. And by remote, I mean the code that I have here stored on GitHub. So there is a whole thing to explain there, but I will be really fast. Simple. For most cases, you will only need to do this. Git push, and it will tell you the current branch has no upstream branch. That basically basically means that there is no corresponding remote branch for the current local branch, right? So if you want to create it, you can just push and add a couple of flags that tells you to set the remote branch with the same name, okay? So I will just copy this, and it's really simple. It's git push set upstream, and then origin, and then the name of the branch that you want, okay? Usually, whenever you type git push and you don't have the upstream remote branch, you can just, it will tell you this message, so you can just copy whatever it tells you here. So I do it, and now notice what it tells me. It tells me enumerating seven objects. Like the objects are related to how Git works and so on, not that important. Yep, you see that it compresses, it decompresses, it writes on the objects, and the most important part is here. So, okay, so here, this one that is creating a pull request. So I want to show you this. So a pull request basically is saying, hey, I want to create a new branch that I want to pull from my local repository, and I want to pull it into my remote repository. As well, the other important part on this message is here. This is telling me that on this branch, and you see that it's marked with a star, on this new branch, right? Sample branch, that it's pointing to the sample branch on the remote repository. We made some changes. And it's saying that the sample branch locally is set up to track the remote sample branch. Okay, so that's it. And now I will show you now what happens, how this changes basically the code, or like the repository. So here you have the link, so I can just go directly to that link, or I just have it here, so it's not important to go. And you see how I have this prompt that says sample branch had recent pushes 2 seconds ago, right? That's because I created a new branch, and well, I made changes locally, and then I pushed. If I take a look here at view all branches, you see how it tells me that I have the default branch, which is main, and the sample branch, right? The active branches are just the branches according to the changes that I did, pushes that I have done, okay? So now you can just you can just press this button that says compare and pull request. And it will tell you the following. It does two things. In the left side, it says the base repository, and that's the repository of my friend. You see, Umberto Justa, brain tumor detection in the main branch. You can pick any branch from his repository. And so that's the target branch. And then the source branch is the one that I created, sample branch. And you can, again, pick the repository. In this case, we already know which repository it is, and also the branch. In this case, we also know that it's the sample branch. So once you do it, so once you set the right target and source branches, you can put some descriptions here of the pull request. So this is an example of a pull request for my students. And then you can type create pull request. By default, GitHub will check a couple of things. So, I mean, any kind of Git system will check that there are no conflicts. And I haven't told you what conflicts are, but you know that if there are several people working on the same code, there will be conflicting logic, and Git tries to take care of that. All right. So once you've done that, the pull request is created, and now the developers, in this case, me, the teacher, and you, the students, will can discuss here the pull request. So basically, I will give you comments on your pull requests related to your assignments. And once I see that it's okay, I will actually approve it or something, okay? So that is it, okay? Now we'll show you the other side of the process. So once you have submitted, right, and created a pull request, what the teacher will do. In this case, I'm the teacher. So let me go back to the original repository, like the repository for your assignments here. And you can see here that there are two pull requests, one from this user and one from this other user. I will just take any of them. I will not review the code. I just want to show you. So here you see how it says, okay, this branch has no conflicts with the base branch. So cool. And I can give some comments. So it's like some example comments to show the class or to show to the class. I can comment, for instance, right? And you can even here assign some reviewers. So in this case, it's cool if you assign me as a reviewer, so I can actually check it out. You can also assign some person for making the merge request, right? So once the pull request has created, you have to, someone has to merge it, and it's ideal if it's not the same person. So yeah, or it depends. Sometimes okay, it's cool if the reviewer is a different person, and probably in our case, because it's homework, I am the one that will be doing the merging. But in many teams, like in real software development, usually the person that creates the merge request or the pull request is the one that merges it. But yeah, so here you can just go here and you can pick a person to be the reviewer. So for example, I pick me here to be the reviewer. Okay. And now I will definitely get a notification that someone assigned me as a reviewer. Cool. That's it. And then I can just here merge the branch, okay? I will press it and it will basically integrate your code within the base branch that I'm using here, okay? So that's the whole thing. I mean, it's only an overview. Of course, Git is much more complicated, and in real software development, you will need a couple, in some momentary occasions, more advanced usage of Git. For example, cherry picking, merging like through the terminal, or rebasing, and several things of that kind. But it's not that important for now. I hope that was good enough as an explanation. So now I'm expecting until next week your assignments, or like your answers for this assignment. And as usual, ask me any questions if you have. Any questions? Okay, cool. Am I sharing the screen?
No.
But I was, right? Before.
Yes.
Okay. I was scared. Okay, cool. Yeah. Probably my friend will text me soon about like, what the hell is this merge request? Yeah, doesn't matter. Okay, so now today I will be talking about modules. So I want to show you the official documentation in Python. And we can try to work along with it, okay? So by the way, like I will probably need to make a small break at 5 and then come back like at 5:20 or something. So at 5, we will have a break. Cool. So yeah, if you want, you can follow along. You can open it yourself. I will copy the link here. Today is very practical, by the way, today's class. So every time that for example, if we are in the Python console, right? If we open it, we define some variables there, whatever, and then we leave, and then we open it again, we lose whatever we did, right? So because we are already working with files, we know that we can actually just do it in a file, and it stores, like the file is persistent, so we don't lose the code. And technically in Python, any Python file, it's a module, okay? And the modules have a name which you can access by looking at this global variable, dunder name dunder. Okay, so let me just copy this example, right? Let me take Python here, and I will create a file here, a Python file. I will call it Fibo, just because it's an implementation of Fibonacci. So you see how I have a function called fib, which is actually computing Fibonacci, and I have another function that is also computing Fibonacci. This one only computes a single item of Fibonacci, and this one stores all the items along the way. Okay, not that important what the functions are doing. So I have that, and I want to show you how you can access this module. I already showed you last week. I gave you a preview, and today we'll just formalize that. So now, let me also create this other example here. Let me see if they have another file over here. No, cool. Okay. So now let me just open the console. Okay. You see how every time that I open the console, I have access, like I have this line here that is saying system.path extend, and then it adds this path, which is the path to the current project. The idea to do that is that now the console will have access to all the modules that I have defined in my project, okay? So now I can actually say import Fibo, and now by importing Fibo, I have access to this file, fibo.py, and I can use it from the console. So I can say fibo.fib, and it will basically call the function fib from the Fibo file or from the Fibo module. And I will, for example, compute fibo.fib of 0, right? This function, notice that the only thing that is doing is iterating and computing Fibonacci's, but because here it starts with 0, 1, it will not compute for 0. Let me call it for 1, for example. So Fibonacci of 1 is 0, then Fibonacci of 2 is, you see how it prints 0, 1, 1, then Fibonacci of 3 prints 0, 1, 1, 2, then Fibonacci of 4, 0, 1, 1, 2, 3, and so on, right? It's basically printing all the Fibonacci's, right? Let's call, for example, Fibo at 10. You see how it prints all these Fibonacci's? Yeah. Perhaps it's not super clear that it's computing the first 10 Fibonacci's, but somehow it's printing them, right? And yep. So now that's how you can import, that's how you can use a module or a file from your console. You can do the same from any other module that is defined in the same route, right? So I will create another folder, another file. I'll call it, I don't know, another module. And now if I want to use the things that I have defined, so methods, variables, and so on, in the Fibo module, I can just import Fibo. And now I can say fibo.fib, for example, of 10. And I can do that. And now if I run another module, okay, you see how it's printing. So I will print here running another module, then fibo.fib of 10, and then, yeah, just to show you that it's actually running that file. Cool. Let's try to add to fibo.py, let's try to add a new, some code, for example, some logics. Let's print, because here I have defined 2 functions, but I'm not calling the functions, right? So here I will say running fibo.py, for example, right? Running. If I run fibo.py, you see how it says running fibo.py, cool. But if I run another module, ideally what you would like to have is the following. It would print running another module, then it will call the function fibo.fib of 10, and that will be all. So it will not print running fibo.py. But somehow, when I run it, you see how it says running fibo.py. So the reason why that happens is that when you import a module, we know that Python is an interpreted language, so it's not that this is compiled. When you import a module, you basically run the module. And because in this module, fibo.py, we are printing running fibo.py, well, it's being executed. So a question is, if I'm importing a module into another one, but the first one is executing some logic, how do I make sure that I only execute that logic when I'm running directly that module, right? Like when I'm actually calling that module rather than just importing it. Well, in that case, I can access an environmental variable, a global variable, which is donder name donder. Let me show you. So I will print here name, and I will show you what it prints, okay? And I will print, So I will run now Fibo. And again, just to show you that I'm running Fibo, I will do it here. So now I run Fibo. And as you see, it prints running Fibo.py. And when I print the variable name, the name variable, it just prints donder main donder. That's the default name. That's the default name for any module that I'm running directly, okay? Now I will do the same here. I will copy this, and I will say, okay, I'm running another module. Then I will print the name, right, like this. And then I will run fib of them, right? Because we're importing Fibo, we expect for these 2 lines to be executed as well. So let's run it and let's see what we get, right? As you see here, sorry, like here, let me run it again. As you see here, it prints. So I'm running another module.py. So the first line is saying import Fibo. So when I import Fibo, it goes to the Fibo.py file, and it runs this line, print running Fibo. That's the first thing that you see. And then it prints the name. But because the name of this module is Fibo, you see how it prints Fibo. Then nothing else happens there. So it goes back to another module, and it prints, okay, I'm running another module. And when I print the name, it prints main. And then I'm running this function from the Fibo module. So as you see, the name variable will be equal to donder main donder for the folder, for the module that I'm running directly. And for any other module that I will be referencing during the execution, it will be actually the name of that module. Okay, so that's cool, because now if I want to execute a logic only if I'm on the module from which I'm running the whole code, I can just do this. If the name is actually main, I will print running Fibo. Okay, so now what happens if I execute Fibo.py? Fibo.py, you see how it prints running Fibo because I'm executing it directly. But now if I run another module.py, it doesn't print running Fibo because we know that we only print that when we're running directly Fibo. Okay. Was that clear?
Yes.
Great. So for those of you who were wondering why the hell everyone in Python is doing always this, that's the reason. There is a comment on the chat. Pretty much. Great. Okay. Cool. So that's how you work with modules. And in this case, I'm importing a module into another, and it's easy because they are both on the same folder. What happens when they are in different folders? Of course, there are different ways of being in different folders. For now, let's do it this way. So I will create here a folder or a directory. I will call it folder 1. And I will move Fibo into folder 1. Okay, cool. And now I will run another module from there. So you see that as soon as I did that, because PyCharm is quite a good IDE, it refactored the code, and it told me that if I want to actually import Fibo, I have to do this. I have to import Fibo not directly, but from the folder 1. So it's very easy. If I have a certain structure where I have in my folder, I have a file or a module, and then I also have a subfolder and another module inside that subfolder. If I want to import the module inside the subfolder into the module that is not in the subfolder, I need to basically refer that folder like this. So notice how I have another module in the root directory of my project, and I have Fibo in the folder, in the folder named folder 1. So when I want to import Fibo into another module, I can say from folder 1, import Fibo. Or alternatively, you can say import folder 1. If you import folder 1, what happens is that folder 1 is just a folder. It's not really a package. So you have to modify a little bit folder 1 to make it a package. But still, you can say something like folder 1.fibo.fibo1, and it will work. So if you import directly the package, right, folder one dot, in this case, folder one, then to refer any module inside that package, you need to put the name of the package dot the module dot whatever you want to use, a variable, a function, a method, or anything, class. Okay, cool. So this will be useful because usually when you make tests, you make the tests in a different folder, so in a different file. So you have a bunch of files for testing, for instance, and all these files are inside a specific folder for tests, and then the source code is in a different folder. So you will need to do that. Cool. For now, it's okay. But now what happens if I now have another module into another folder? So I'll create a new folder as well. I will call it folder 2 here. And I put another module inside folder 2, okay? Like that. Now, you see that PyCharm didn't change anything on the code. Like it says import folder. So let's try to see if it works. So another module, I will run directly another module. And as you see, it tells me an error. It tells me folder 1 has no attribute Fibo. That's a problem, right? That's a problem because we have, in folder 1, we have Fibo well-defined, right? So now we need to fix it. So in order to fix it, yeah, I have a comment here. Need to add init to that folder. Great. Yep. Well done. Or well said, whatever. So now we need a couple of things. The first thing is that we can do the imports in different ways, right? For instance, if you add, remember when we open the console here, the first thing that happens is that we are extending our path with the path of the folder of the directory. Well, we could extend it as well with the path of the folder, of folder 1. And then we would have access to Fibo. And that would be all. Similarly, you can extend it with folder 2 as well. But that's not nice because then you would have to do that for every folder you have or for the ones that you care about. It's also not very good from the point of view of the structure of your code. Instead, we try to do several different types of imports. So you can try to import the following way. You can say import, and then you can go to the parent folder, and then you say folder 1. Yeah. What's happening here? Okay, we'll fix it now. Okay, let's do it this way. Port folder 1. You see how it gives me an error. So the first thing that we will fix is what Victor said. That is when you create a proper package, right? When you create a folder or a directory and you want to put modules inside the directory, then we have what we call a package. And in order to do it properly, you need a file, which is the init file, which many times it will be empty, okay? And in some of the cases, it won't be empty. I will show you now how it can't be empty. So yeah, here I created empty, and I will show you that in Python, you can also create a package by saying, well, I want a Python package. I will call it folder 3, okay? And basically, it is just a folder with the same name as folder 2, with the same structure, with the init file, which is empty, by the way. And well, it's nice that in PyCharm, as long as you have the init py folder file inside your folder, it changes the icon to, in a way, to represent that it's a package, okay? So a package is nothing more than a collection of modules that you want to provide, either publicly or privately into your code. Here we'll also create the init file. Cool. Good. Okay. And now that we have defined that, how do I define my folder 2, right? So I want to import folder 1. I can now just say import folder 1, and let's try to use it. So I will do folder 1.fibo. Was it fibo? Yep. .fibo. .fib. Was it like this? Of 10. But as you see, it tells me I cannot find Fibo. You see, I cannot find Fibo in referred in the or referenced in the init py of my folder 1. So the init py, in a way, it's to initialize the package, will basically tell me what I have to import from that package publicly. So to be able to use the package. In my case, I want to import Fibo. So I will say import Fibo, right? So I will import Fibo. And this has an issue, but I will show you later. I want to show what the issue is first. So I import Fibo, and now I have Fibo well imported in ini.py, and the init.py file is the one that we have access whenever we import a package from another one. So when I import folder one, I'm actually accessing ini.py from folder one. And because in ini.py of folder one, I have imported Fibo, now I can access Fibo, technically. So let's try to run it, and let's see what we get. We get another error. We see that we have no module named Fibo. Does anyone know the reason? There is a reason. Can you try to guess? Perhaps a hint is this command here. So when I press the run button in PyCharm, this is the command that is being run. Python, and then it's running another module directly from, another module.py as a file directly from with this path here. So it assumes that Fibo, it's either a module in Python, or it's defined in the same folder in which I am, right? So in order to fix it, I have to do two things, or perhaps only one. So I go here to init, and instead of importing Fibo this way, I import Fibo this way. I'm saying that okay, ideally it should be like this, but it's not working. Why not? Okay, okay, I guess I can keep it like this. Okay, let's keep it this way. I will import Fibo that way. And now I will just run my module in a different way. So I'll do this. Okay, so let me put this here like that. Oh no, sorry, my mistake. So I will just run it as a module. And for that, I will use the terminal. I will do this. Python is my interpreter, -m, that allows me to run a module, right? And in that case, I want to run another module, right? So then I put the path to the module. So it's folder2 dot another module. I don't need to put .py, and the path is written with dots, okay? Rather than as a path. It tells me that no module named Fibo, again. I have folder1.fibo, and here I have imported Fibo. Okay, what's the problem then? No. So I have folder1, and here py import folder1. I'm not sure now what's happening. I thought that this was going to work, but let me check. Wait, once again, perhaps it's something that I'm not following. So I'm importing folder1, and folder1 is importing Fibo, and Fibo should be working, right? So I'm importing folder1, and now let me say help of folder1, for example, just to see what's happening. Wait. Okay, so when I import folder1, it goes to folder1, okay, and it tells me that Fibo does not exist. So it should be like this, no? Why is it not working then? Okay, let me check the documentation, because I've done it several times and now it's not working. Perhaps something that I haven't checked. Right. Okay, so here they have actually a good explanation. So I have, for example, a package, which is sound, and you see that it has init.py. Then I have these folders, formats, effects, and filters, and I have a couple of modules on each of them, right? And then in init, so let me see. The init file here, it's okay. Yep. But it can also, okay. Okay, I think I know what the problem is. Is it because I forgot to put the init file here? Is it? Is it that? Not sure. No. I'm actually not sure. By the way, if anyone noticed what is this silly mistake, tell me, and we can save time. But it's actually a good experience that we are facing some issues, because you can see how to debug and how to check documentation. So ideally, this should be working, but it's not. We can now try to look up the documentation, right? So
Maybe in command line another model point pi add point pi. Yes,
no,
no?
no, not really. It should be like that. It should be like that without the pi.
Okay.
Yeah, let's see. Import folder one. So when we try to import folder one, we cannot import init. Okay, let me try to run init here. For example, what happens if I run this? It works, right? It just works. I can import Fibo here. What happens if I try to say, okay, what if I do this? Folder one, not Fibo. No, 1 second. So init is importing for Fibo folder Fibo. Okay, here, this is cool. And another module is importing folder one, and folder one is importing. Okay. Let me do this. And I will take init and I will comment this line. And I will still look up the documentation of folder one. So let's see what we can get there. So it tells us, yep, folder one. The name is folder one. Okay, the package content, it contains Fibo. Cool. So it tells me that it contains Fibo. And this is the file. Cool. Because init, okay. Why is this not working? What if I do dir of folder one? Print it. Print. Okay, then let's look up the documentation. So, okay, so when importing the package, Python searches through the directories in system.path. Cool. Looking for the package subdirectory. Yeah. The init.py file are required to make Python treat directories containing the file as packages, unless using namespace package. Okay. This prevents directories with a common name, such as string, from unintentionally hiding valid modules. Okay. That occur later in the module search path. Yeah. Users of the package can import individual modules from the package, for example, import sound effects echo. Okay. Okay, I think it was my mistake. Okay, cool. Now we can. Okay. Sorry, my mistake. I assumed that we could do it this way. Okay, so now, okay, so back to the thing, right? Here we have init, which is empty. Okay, let's keep init empty for now. And you see how the package folder one has the init method, the init module, which will be empty for now, and the Fibo module, right? Now in another package folder two, we have a module called another module, and we are importing the Fibo method here from the Fibo module, sorry, the Fibo module from the folder one package. Now let's see if it works. It works because we are importing directly the module. Okay, yeah, my mistake. We cannot import a package directly. I mean, what you import are modules, and if you want to import all the modules from a package, then you can do this. From folder one, import everything, right? And then we are importing every module from that folder, or you can, import Fibo and whatever else you want to keep. So yeah, so that's it. Okay, my mistake. So we have another module, and in another module, we are importing Fibo, right? So you say import folder one.fibo. And now you can access it by saying folder one.fibo.fibo. And it works just out of the box. Great. Cool. So that's how you do it when you have this nesting. Like you have, a file, like you want to call a module from another module in a different package, right? So you do it this way. Cool. So basically that's how you see it here. Like you can try to look up to read the documentation if you want more examples, but basically here you have the global package and then you have all these packages, right? Like formats, effects, filters, and so on. Notice that now it will work, like the terminal command, it will also work. So if I do this, yep, it works as well. Ideally, I prefer it this way rather than running the file because this is telling me exactly what bot to choose. Like, running it as a module, it just looks better from the Pythonic point of view. Okay, so now that's how you do it. But what happens if you want, for example, so if you want to now run, let's say, let's create a module here in the global one. So I will call it global module. So now what happens if I want to, so notice the structure, okay? I have here, let me see. So I have folder 2, right? The package folder 2, and I have another module, and I'm running a module from a different package. Cool. But I also have this global module, which is in the root directory, and I want to access it from another module. How can I do it? Well, I can do this. I can import. So I can do a couple of things. The first one, let's try to import global module like this. Let's see if it works just out of the box. And as you see, it actually works. Well, I mean, global module, it doesn't have anything. So let me just show you. Let me print here, name. And then let me print also, running global module. Okay. So now I import global module from within another module.py. And as you see, I can access it very easily. So it's running global module and global module. So that works because global module is defined here for my directory. And remember that when I run my file here, I have access to that path. So it's already in the path. What happens if I try to run it this way? It also works. Very simple. Because global module is defined there. Okay? It's defined there in Python in my root directory. And now the last example is the following. I will create a new, let's say I want to put, okay, I will create a new folder, a new package. I will call it folder 4. Cool. And now I will move folder 2 inside folder 4. Okay. I will do refactor because the refactoring will tell me exactly how to change everything. Cool. So now I have my refactor. And now I want to access here, sorry. I want to run another module from within folder 2. So let's see. Let's run it. It works. Suddenly, we have access to folder 1, right? Which is great. And that works because folder 1 is defined in my root directory, right? It is defined in my root directory, so I have access to it. But what happens if I put folder 1 inside folder 4? I move it, and you see that it tells me to refactor, and as soon as I refactor, I have to change it. Because now folder 1 is not defined in my root directory, so I have to first access folder 4 and then folder 1, okay? So now I can run it, and it just works. Very simple. All of these are absolute paths that come directly from the root directory. We can also have relative paths. So definitely, that means that if we start in some specific directory, we can move up and down by using dot. So it will basically go to the parent folder, and dot, which will make reference to the current module. But yeah, but for now we will use absolute paths. Okay. Any questions so far? Was it clear the problem that we were facing with the imports and how we fix it by making packages and importing exactly the modules that you want? Is it clear? Is it not clear? Clear. Great. Now, if you took a look at the documentation while we were trying to fix our problem, you can see a couple of things that are quite interesting. So in particular, which is the one that I want to cover? No, none of this. No. Where is it? Oh, here. So this is what I was telling you, right? Like you can use relative paths. So when and here, like I guess in the official documentation, it's called intra-package references. So when you have packages inside other packages, right? You can use absolute imports as we were doing, right? But for example, if the module sound.filters.vocoder needs to use the echo module in the sound.effects package, we can import it this way as we were having as we did. But we can also do it relatively this way from the module, import the name, right? And in that case, we specify whether we want the current path or the parent path, or from the parent path a specific module. So, yep. So for example, here, right? If we are here on folder 2, let's try to do it actually. Does packaging dots before module name work for every platform? What was the answer? I actually don't know the answer to it because I never use Windows for development, so I don't know. And in Linux and Mac it works, so I don't know if it works in Mac, in Windows. Sorry. What was the answer, Victor? Can you tell? In the documentation, I didn't see it. I'm talking about the message in the chat. Wait, whatever. Right in the table. Right in the table. Which table? Anyway, it doesn't matter for now. Cool. So let me go back to this. Okay. So yeah, you can do that, right? Let's try to do it here. There is no difference in platforms. Cool. So so we have another module, right? And we have these these absolute imports here. Let's try to do absolute paths. So I will do this. So I want to import, for example, I have folder 2. Okay, let's see. I have another module inside folder 2, right? And I want to import Fibo from folder 1. So I can do this. From my parent folder, .folder 1, I want to import Fibo. This should work. But it's not working. Oh, let me see. Okay, so import folder 1 dot Fibo. Why is not working? Isn't that what the documentation asks you to? Yeah. So from my parent path, from my parent path .folder 1, I want to import Fibo, right? So yeah. So now I'm doing it in a relative pathway. So I'm saying, hey, move to my parent path. So I'm in folder 2. So move to the parent folder. In this case, would be folder 4, right? And then I go folder 4/folder 1, and then Fibo, right? So now I have that. And because I imported Fibo directly, I can just say Fibo.fib, right? And it just works. I run it this way. Oh, sorry. It tells me that there is a relative import with no known parent package. And that's the problem. You see, that's the problem of running directly a file. So I'm saying Python, and then I'm running this file as a single file. So that's why it's ideal to run things as modules. So I will run now Python -m. I have it already here. Folder, in this case, should be folder 4.folder 2. Another module. And now Python understands that the package folder 2 is has as parent package folder 4, right? So now if I run it, it works. You see? So that's why running here with this button here, like if you just run it this way, it's not nice because what is being implemented here is just running the file. You can configure it to run it as a module there in PyCharm, but if you're gonna do it, then just run it from the terminal. It will work just fine this way. Okay, cool. Similarly, we can try to go even upper. So we can say go 2 steps up, then 3 steps, folders. Let's see. So I'm where am I, right? Let me do this. Let me create another file, another module. So I'll call it module 3 or something. Okay, inside folder 2. And now I will try to import something from module 3. So in module 3, let me have a function. I will call it fib3 or something. Okay, it just says, I don't know, whatever. Okay, doesn't matter what. Let me say, okay, let's say print running pip3. Okay, that's all. So now in another module here, I will try to import module 3. So, but in a relative way. So I will say from here module 3 import pip3. Okay, so I can do that, and I can say pip3 of 10 or whatever, for example, doesn't matter. I just need 3. Was it like this? It receives n, but it doesn't do anything with it. Okay, so I run pip3. Cool. Also in a relative way. And now, lastly, I want to import something from folder 3 in my another module, also in a relative way. So let me create here some specific module. So I will call it random module. Sorry for this very bad examples, but the important part is the structure of the code rather than the semantics of what we're doing. And here I will create a function. I will call it say hello or whatever. And the function here I will print hello world. Okay. So now it's a function that just prints hello world. And now I want to import random module from folder 3. How can I do it? Well, by the way, if you don't remember exactly how you should do it, and you're creating your project from scratch, and you can Google the answer, for example, or you can do this. You can put random module inside folder 2, and you know how to import it. And then inside PyCharm, then you can move it to folder 3 and click the button refactor, and it will change the code accordingly, right? So it will fix the problem for you. So now we want to access random module. So we can do this. So in folder 2, we will have access to module 3. So I will go up. Then I will say folder 1. No. So if I go up, I basically am on folder 4. How can I access folder 3? I'm actually not sure if I can do it relatively. Perhaps there is a way. I think with 3 dots, perhaps. Folder 3. Can I do that? And in this case, I want to import random module. Let's see if I can actually. I'm not sure. And then let me say random module dot say hello. Okay, as soon as I try to access it. Okay, I can actually, apparently. Okay, so with 3 dots, I basically go 3 parents above. I go right to folder 3. I go right to the directory, to the root directory, and then I refer folder 3, and then I import random module. Probably you will never, almost never, you will need to do this, but it's good to know that you can do it, right? Once again, if I run it this way, I have a problem because I don't have my file as a package. I'm running it just as a file. Instead, I run it as a module. Whoop, and now I have a problem. It tells me attempted relative import beyond top level package. Am I not doing it this way? Second. Interesting. Okay, apparently we can't, or what? Folder 3, random module. And it tells me attempted a relative import beyond the top level package. So if I go twice, does this work? It doesn't. Okay. If I go 3 times, well, it seems that we cannot do it. I'm not completely sure why actually. But yeah, I actually have never had to do this in any project that I've worked with. Okay, so that would be all about the relative imports. And now let me just check that it works. So I will just run everything. Yep. Sorry, with like this, and it just works. Okay, cool. So now that we have all of that, let's talk a little bit about how you should structure your projects. So I will create an empty project once again. Random project. I will go PyCharm random project. Oh, sorry. PyCharm here. New window. So I have my empty project, and now we'll just create it from scratch just to show you the structure. So the first thing that you want to do is to create an environment, right? So I will do this. Let me check my Python version. Let me check which one I'm running. Okay, I'm running my base Python, right? The base installation in my computer. And with it, I create a new environment. Python 3 minus n virtual environment, virtual environment. I create the virtual environment. I have it here. Then I activate my virtual environment. So I go virtual environment, bin activate. Right? So now I have my environment activated. I can show you here. I check which is my Python. It's the one in my virtual environment. Cool. Then, so I'm just showing you what you should do if you start a project from scratch. Now I have it. Ideally, if you're using PyCharm or whatever IDE, you should make sure that the interpreter that the IDE is using is the one in your virtual environment. So let's do it. I want to use a local interpreter. Select existing. And now I can just put here the path that I want. So I have to go to my random project, virtual environment, bin Python or Python 3 or whatever. Okay. Yeah. Okay. So now I'm using that one. So now that we configure that, let's go and create a Git repo, right? So the first thing that you do is git init. That creates a Git repository. You see, initialize empty Git repository. So now if you take a look at Git status, it tells me on the branch main, no commits have been made, and there is a file idea, a folder idea that that is untracked. The reason of why that happens is because since we are here, if you take a look at what we have this Git file. This Git file is the one that it's created when you start a Git repository. Let me show you what it has, what it contains. Charm.git, this window. I mean, it's a folder, sorry. It has basically all the structure of Git. And we will cover perhaps a couple of these things in our Python, in our second semester. I actually should have gone here. Let me go back to this. Yeah, this window. Cool. So I have that once again. Oh shit, I have to activate my environment once again. Okay, so I activated. And now, yep, so that's the Git folder. And now I also have a folder idea, which is containing the configurations related to the JetBrains IDE. If you have VS Code, you will have some VS Code folder there. You don't want to include that in your project, in your Git repository, right? So in order to not include it, you create a folder, a file called git ignore. And that git ignore will contain the folders or files that you don't want to include in your Git. Okay. For Python, there is a standard or two standards for what the git ignore usually should be, because there are, usual files that are created in standard Python files. And you can just copy it. I will copy the whole link here. I'll paste it. You can just copy it and use it as your git ignore, as your default git ignore. And then if you are using PyCharm here or whatever idea whatever JetBrains IDE, also include this line to exclude the idea folder, right? And that will basically make sure, it will basically exclude the standard files and folders that you have when you have in different frameworks of Python. So for example, here, Django, which is a set of libraries, a framework for web development, also Flask, Scrapey. We will see Scrapey in our course in a couple of lectures. It's related to web scraping, so very good for data science. You will see also that when we have Jupyter notebooks, we need to also exclude this folder here. And depending if you're using a different package manager. So we are using pip and we're using a virtual environment, so it's not a problem. But I will show you later in a couple of lectures that we can use pyenv, it's nice, pipenv, even this one is nice, poetry or UV. In particular, I will show you these two, UV and poetry. And in that case, you need to probably exclude these ones here as well. Okay. And similarly, it's standard to have this folder for your virtual environment or this one, to have this file for environmental configuration. I haven't shown you yet, but we will need it later when we need APIs. And yeah, we will also see Python a little bit in a couple of lectures, so you will need also to exclude this folder, okay? So yeah, basically this tells Python to exclude all these things from git ignore, not Python, sorry, Git, to include all this from the Git repository. So now let me show you. I have all of this, but if I go to git status, you see how it doesn't include the idea folder anymore. But instead, it includes the git ignore. So what I will do is including the git ignore in my repos. I will say git add git ignore. And now if I go to git status, you see how it says the git ignore file is staged to be committed. And before committing, I will create another file. So I will call it readme.md. So readme.md is the standard markdown file that you use in order to have this page on your repository here. You see here, it says readme. That's exactly that file, readme.md. Okay, so it's useful to put documentation, description, instructions for installing your project and so on. And in our case, we have quite empty, so I will just put here the title. So you need to use Markdown, like it's a language for it's a markup language, but it's very simple. You use hashtags for headers and double hashtags for headers of smaller size and so on. So in this case, I will put the title of the repository, which is random project. Okay, and then some instructions. This is a random project. That's all. Cool. Then I will put instructions for how to clone it and so on, just to show you how you should, what is an ideal structure of a README. Okay, so now that I have it, I will show you that if I type git status, I have this file here and it's untracked. So I will track it, git add readme.md. And now if I say git status once again, it tells me that I have the git ignore and the readme, right? So now I'm ready to commit. I will say git commit, and the message will be something like press commit, for example, or initial commit or something. Then I will say git push, and once again, it tells me, hey, I haven't configured the remote URL, right? That's because I created my repository directly from my, like, locally. So now if I have already some remote repository, or if I want to create it, I will need to put here git remote add, and then the name that I want of the repository and the URL. Actually, you can do it, but if this is confusing for you, when you create the empty repository in GitHub, it will tell you, hey, do you have already an existing repository locally? And you click on it, and it will tell you exactly the command that you need. But it's not that important, okay? So that is it, right? I have my virtual environment with the Python that I want, the README, cool. And now let's have code. Usually people create a package called source, which include all the source code, and perhaps a package called tests, which includes all the tests, right? So you can either say create new, right? And in this case, we'll call it Python package and we'll call it tests. And then inside here, I will create a new file that will be a unit test. And I will call it, I don't know, first test, for example, or test something. Okay. And notice that when you create a new test, it starts with this template, right? You already understand now what this means and what this means as well. Of course, unit tests haven't been imported, so you need to import it. As well, because we are using a virtual environment with pip, a good idea is to ship your code with a file called requirements. PyCharm doesn't tell you to create it here, so I will say, okay, create a new file, and I will call it requirement.txt. Okay, and that file is the file that will contain all the packages and modules that you have to install to make your project work. PyCharm is smart enough, so it tells me, hey, import packages that I'm already importing. I will say, okay, do it. For now, I'm not importing anything, so that's why. But for example, I'm importing unit test, right? So if I hover over it, it tells me, hey, install package MicroPython unit test. Or I can just put it here, unit test. I put it there and it's highlighted and it tells me unit test is on the requirements, but it's not installed in the packet in the current virtual environment. Once again, sanity check that we're running the correct interpreter. So let's go here and I would say interpreted settings. And you see how it's wrong. I knew that it was going to be wrong, so let me change it. Let me use the right one. It should be a different one, right? We know that it should be a local interpreter, and it should be this one. So you see how it says that it should be on VMV. Sorry, select existing package. Python. Okay, it's not working properly. The UI. Okay, here. Yep. Python here. Okay, cool. Okay. Why is it user being indent? It should not be there. Oh, the interpreter. Okay, I'll just copy then the path to this interpreter. Okay, so I'll just go here. Well, so annoying. Okay. Let's do this. I will go to VMV, then I will go to bin. So I have some here, and then I will do this. Actually, I don't need to do that. I will do it this way. I will say which Python do I have? This one. I will copy all of this. Okay, and now we'll modify it on the settings. Yep. Add a new interpreter, local interpreter. Select existing. Yeah, and now if I go to manage packages, sorry, manage interpreters, interpreter settings. So weird that it still tells me that. Why so? Like, okay. That's because we created it. No, it's using indent and it should not be. Anyway, it doesn't matter. Like, I will use the terminal then because PyCharm is annoying. I will use the terminal, okay? Okay. The terminal is okay. That's because I created the interpreter directly here, like this, right? But I think if let's see, if I rename VMV to .vmv, what happens? Okay, I do it. Let me rename it again. .vmv, refactor. It does me an error. Okay, let's do it this way. I will open here and I will just rename it manually. Okay. Yep. Come on. Okay. Then okay, let me just create it again. I will create VMV, but this time this way. Okay, let me do this way. Python minus Python 3 minus M. First, let me create a new terminal. Okay, without VMV activated. Okay, then I will remove the current VMV. I'm just trying to like add this environment into the settings of PyCharm, which is not working properly. So yep. So I have this. Okay, I can either create the new environment there, but I want to create it with within the terminal and then add it to PyCharm. Shouldn't be that hard. So I'm here. I create the new environment VMV with the dot here. Okay. Cool. So I have it. Then I will activate it. Yeah. Cool. Then I will go here and I want to change it. I want to use a different interpreter. I want to use a local interpreter, an existing one. Yeah, please Python 3 or whatever. Yeah. Okay. Okay. And now what do I have? That's so annoying. Why? Let's see. I mean, Python is being you see Python here, it's being linked as a symbolic link to Python 3. 3.13, and Python 3.13 is linked to this one here, which is the base Python that I have. I shouldn't have user being ident there. I think it's a bug from PyCharm. It seems like a bug. So if we can do it that way, then I will create the environment from the UI of PyCharm, and I believe it should work now. So let me remove it once again. I'll close this one. I'll open a new one. Yep. Let me remove once again .env. Cool. But ideally, it should work properly. And now let me just create a new interpreter. Add new interpreter, right? No, add new interpreter not. It's like interpreter settings. And I will say add interpreter. How can I create a new interpreter? Isn't it like this here? A new environment. Project, random project, right? Project interpreter. I will use show all. No. What if I use this path here, right? Oh, but I don't have it anymore. Let me do it. Let me create it again. 3 minus nvmv. I created it. Now let me go here. Let's do it. Okay. See, it's not working. Like I just changed the path to be a different path, and it's not working. So annoying. Anyway, let me see if I can. Yep, not working. Anyway, that already tells you a problem, right? With the packaging system, like with the version, with the package management system in Python. As a matter of fact, probably next session or the one after it, I will show you a very recent new package manager, which is called UV. It's written in a programming language called Rust, and I have seen a lot of adoption from the Python community, and it's supposed to be faster, lightweight, and consistent. Before that, I will have to show you a lot of different other problems that standard package managers in Python have, like Conda versus pip and so on. And after that, I will show you a solution with UV, which is a new package manager. Anyway, we know how to do it. Forget about PyCharm. Let's use the terminal for now. Okay. So I have this, and now let's see, what do I have here? I have my random project, and I have my virtual environment. Let me activate the virtual environment. Sorry, like this. So I activated it. Now, so I have my environment, right? And when I have my environment activated, I want to check, for example, which packages I have installed in my environment. I can do this. First, I can use pip, which will tell me exactly, which is the package manager. And to check that I'm actually using the package manager from my environment and not the global one or from a different environment, let me do this pip3 minus version. And you see how it tells me that it's pip from the environment, you see? In Python 3.12, which is the Python in this environment, okay? Cool. This is cool, so now we use pip3. What happens if I use pip? It's also in my environment, so I can use either pip or pip3 and it will work just fine. It's the same thing, okay? And that is because if I go to my environment, you see here how pip, it's a command, pip3 is another command, and pip3.12 is a different command. Actually, I was expecting that they would be linked to each other, but they are not. Anyway, it doesn't matter because it's good enough. Pip is always attached to a Python interpreter, okay? Cool. So now you can do this, pip list. And it will tell you the packages that you have installed, okay? In this case, we only have pip. You can also check, let's see. Is it this? Okay, I have done it before, so I should have it here. I don't have it anyway. You can also do it in a nicer way. Like there is a different way of doing it without showing the package and version. I think it's like pip list minus E. Is it like that? Minus format or minus format equals to freeze, like this. So if you do this, it will basically tell you pip list format freeze. It will give you each package with the version that it has. an empty Python environment obviously only has pip installed. So now let's install unit test. So we'll do this, pip install unit test. That's all, right? To check that actually this is what you want, you can take a look at the official documentation of unit test. So unit test Python, right? This is the official documentation, right? And yeah, we can try to import it. We can try to use it. So, I mean, technically we should have access to it already. So let's see here. Yeah, you see how it says that package requirement unit test is not satisfied? I will not use Python just because I didn't manage to set it up properly with the right interpreter. So I will do everything from the terminal. So let me just try to install unit test and let's see what we get. Yeah, there is no unit test. Probably we should install unit test 2 then. Yeah. Notice that when we install it, we say pip install the package. It tells, okay, we are downloading a bunch of files, some wheel files and so on. I will explain you in a couple of lectures what the wheel files are. And at the end, installs some dependencies, and now we have it. And if the pip version that you have is not the latest one, it will tell you, hey, there is an update. Use it if you want. But now we have it. And now, let's see if we can use it. So I will open here my console, Python, right? And I will try to import unit test. Now I can use it, you see? So if I try to show the list of pip, my pip list, it tells me not only pip, but also unit tests. And obviously also all the dependencies that unit test requires. So this is cool because now you can exactly manage what are the packages that you know. A good idea is to store these packages in a file. That's the requirements file for what the requirement file is for. Okay, so what we do is we print the list of requirements and we will put it in the requirement files. Okay, probably I should go to here and then do that. So this shows the list of requirements, and then the requirements file will store it. So you use this syntax from Bash, which basically tells me the output of this command will be appended to this file. Okay, that's it. So now we do it, and if we take a look at the requirements file, we see that we have the packages that we have currently installed. That's cool. So what I want to show you is that that's a good structure of a project, at least with pip. You have a requirements file, you have a virtual environment file folder, you have your tests, and you have your source code. Perhaps another file, .mv, which we will see later, that will be for storing, for example, API keys and things of that kind. Okay, so that is the structure that I want to show you. And then in the source folder, you can use exactly what we just covered with the subfolders and so on. Okay. Any questions? Sorry for all the problems with Python, with the Python interpreter. Yeah, it shouldn't happen with VS Code. It should be okay. Not sure why PyCharm was not working. So weird. It's the first time that actually happens to me. Yep. Any questions? Okay. I will assume there are no questions. Now, let's go back to the modules. You can, if you want, and it's actually a cool idea to do it because perhaps you will need it for your next assignment that I will publish this week, which will be related to modules and so on. It's a cool idea to read the whole documentation. The last thing that I want to cover about the documentation, from the documentation of modules, is this variable, all. So all, like I think the whole, here it is. Right. If you have inside a module, you have a package, right? And in the package, you have a module called init, which almost always is empty. And I mean, it can work empty. In init, you can, for example, start something that will take a lot of time to run, for instance, right? Or like, yeah, the initialization of the package. Or you can also use this variable. It's a global variable, or at least a variable that will be in the namespace of the current module. By the way, each module has its own namespace. And it will tell you, yeah, like in there, you will define the modules that you have to import when you try to import a package. So by default, when you say from a package, import everything, it will import everything. But sometimes you don't want to import everything, right? You just want to import the ones that you care about. And in that, to do it, you just take a look at this variable and you list the names of the modules that you want. Okay? So for example, let me show you. Here, let's see, in folder 4, yeah, folder 4 is a good one, right? Yeah. Let's see. Yeah. So in folder 2, you have another module and module 3. Now let's take a look at, okay, let's do this. Let's take module 3 and I will move it to folder 1, okay? Yeah, I will refactor, cool. So now from another module, I'm using, I'm using module 3 here and I'm using FIBO. Let's do the following. What happens if I want to do this? I want to say from folder 1, okay, from folder 4.folder 1, import everything, right? That will import FIBO and module. So I can do, so yeah, when I say folder 4.folder 1 here, I have init, but init doesn't do anything. So now when we are on another module and we try to access FIBO, for example, .fib, it doesn't work. It tells me FIBO is not existing, even though we are importing everything from folder 1. Well, because importing everything from folder 1 is actually importing what is defined here on init. And you can either on init, you can import, for example, FIBO and module 3 as well, right? Like let's import FIBO, for example. I can import FIBO, and then in another module, I will have access to FIBO, you see? So now I can run it. So I think so I think this should work, but it's not the standard way. I want to show you first, and then I want to show you the standard way. So I have it. You see how I'm importing from another module, which is inside folder 2. I'm importing folder 4.folder 1, everything from it. But everything is only technically FIBO. So I will try to access from my another module. I will try to access FIBO.fib, and I will also try to access module 3. You see, I cannot access module 3. Now let's see if it works. So I will run -m, then folder 4.folder 2 dot another module. Yeah, it tells me FIBO is not important. It doesn't work. So instead, I go to init, and instead of doing this, I do this. I define this variable, and I say that now I want to basically have FIBO, and I want to have module 3. Okay? So I define it that way. And now when I'm here inside another module and I'm importing from folder 1, I'm importing every module. Now I can access FIBO.fib just fine. And I can also access module 3 dot say hello. I think it was the method, right? Was it module 3? Module 3, it's saying, fib3, sorry. So here I will use fib3. I can say module 3 dot fib3, 10, for example. And it will just work. So if you want to import everything from a folder, you have to define it on this variable here in the init file, okay? So yeah, that's more or less what I wanted to cover from it. Perhaps, so we have 13 minutes left before 5. So let's cover one more thing. Then the next thing that I wanted to cover was the sys module. And yeah, so we can create our own modules, right? But we can also use the default modules, and I have already used them, like the math library and a couple of other libraries that I have used so far, like unit test, for example. In particular, there is the sys module, and you can take a look at what it has. So we can do it, right? Let's go here on the console, and I will import sys, and I will first take a look at help of sys, and this is what we got. Sys, the following documentation is automatic. Oh, okay, so this is the, yeah, I mean, this is generic. We don't need it. Here it is. This module provides access to some objects used or maintained by the interpreter and to functions that interact strongly with the interpreter. So we have some objects like argv, which contains all the arguments of the when we run the script, right? The first one, it's the name of the script. It's the path name of the script, right? Then we also have an object that is the path, which is the path, the list of directories that the interpreter will look into to access different modules, right? And then the modules dictionary, okay? That will have the name of the module and the module itself. We have these two, which we will not need. And then we also have standard input, standard output, standard error, which we have used already when printing in different files. We have these ones, which are very nice. These ones allow us to access the last exception that hasn't been caught by a try except block, the last type of the exception, of that exception, the last value of that exception, and the traceback of that exception as well. This is nice. You can try to use this in order to implement some debuggers and so on. It's a nice project, by the way. Implement your own debugger, right, in Python. Then you have the built-in modules, which are all the modules that we have used, like math library, whatever, unit tests, perhaps. And then a couple of other ones that we don't need for now. Like we used the version some time ago, I think. As well, we have a couple of functions like get profile. We will work with it later when we do some debugging. Get the size of some objects in byte. Get the recursion limit. Definitely we will need this. And so on. It has a couple of submodules like monitoring. We will not use it for now. And you can even take a look at the detailed documentation of each of the modules, right? So that's the sys module. And it's very cool, right? Yep, that's a module that I wanted to show you. Any questions, or is everything clear so far? I sent a link to the documentation as well, so you can look it up as well. Okay, then I suggest to have now the break. Let's have 20 minutes of break. And we can continue in 20 minutes. Yep. So let's do that. See you in 20 minutes.
Okay.
Yep, see you.